All right, class, Bean here, and this is AP Physics, Unit 1 Motion, um, homework number 4, Vertical Motion. This one here, we're going to be looking at Dump Tower Level 2 hints. Dump Tower Level 2 hints. Let's slide this over here, and let's kind of see what happened here. Oh, looks like Baby Yoda already did it, and looks like Baby Yoda used the Force and was able to get things squared away. All right, so Baby Yoda can do it. I think we can do it also. So let's go ahead and let's reset this, and let's kind of see kind of what's going on here. So in this program, you will have an object dumped off the top of the tall tower, and you must find the time it takes the object to move between two specified floors of the tower. You will also need to calculate the average speed of the object as it is moving between your two specified floors. This scenario is occurring in a far out corner of the universe, and thus you will not be using Earth's gravity for this calculation. All right, so let's go ahead and click on it and let's see what we got going on here. Okay, so here we have the tower here. The tower is 87 stories tall. A massive object is dropped over the side of the roof of the tower and accelerates down toward the ground. The gravitational field strength of this planet is 14.73 newtons per kilogram, or it's meters per second squared. You will start tracking the object when it has fallen 9 stories. Okay, this is 9 stories from here to here. And you will stop tracking when it has fallen 64 stories. Okay. Each story of the tower is 3.46 meters tall. How many milliseconds will you be tracking your object, and what will be the average speed during the time you are tracking? The ball will not drop until you submit your answers. All right, so first things first, let's go ahead and so the ball is going to be dropping downward. So let's go ahead and get our frame of reference. So in this case here, we're going to go down, right? Is going to be positive, like so here. Therefore, G is also going to be positive. And in this problem here, we are given that G is 14.73. So we'll go with 14.73 here. There we go. Okay, meters per second squared. All right, so and also we're going to be starting from rest, right? So VO, so initial velocity is going to be 0. Okay. All right, so we're dropped off from this tower from this point right here. So let's go ahead and kind of draw a line here to show our first reference point. So here we know that VO, as we stated already, is going to be 0. Okay, so let's go ahead and calculate our initial height. We'll call it y0. That's going to be our initial height here. Y0. Our initial height here is going to be, looks like it's 87 stories tall. So 87 stories, times 3.46 meters. So 3.46 meters. Okay. That'll be our initial starting height right here. Now, right here is when I'm going to start. It's going to start tracking right here. So we'll make this another point of interest here. Now, it's going to start from rest, but when it falls here, it's going to increase speed because of acceleration. So here, there's going to be what we'll call this V2. There's going to be a new, what we'll call V1. There's a new velocity here, 1, and there's also a new height, and we'll call it Y, maybe Y2, right here, right? Y2. Okay, just in case we might need that height. In fact, we know what y2 is going to be. So it has fallen 9 stories. So it's going to be 9, right? 9 times the 3.46, 3.46. Okay, that'll be the new y. So the ball is going to be falling. It's going to be gaining speed until it reaches the end tracking point. This position here. There's going to be a new velocity here. We'll call it V2. And there'll also be a new Y. And we'll call it Y2. Okay. And this This distance here is the distance is so y2 is this distance here from here to here. Y2 is from here all the way to here. And that's going to be given as, looks like 64 stories. So we have 64, okay, 64 here times 3.46. So 3.46. All right, so let's take a look. Let's see what we got going. At this position here, the initial height is uh, uh, 87 stories high, and each story is 3.46 meters. So that's going to be YO. Initial velocity is going to be 0. It's going to drop. It's going to gain speed until it gets to this point here. When it reaches this point here, it's going to have a new velocity, V1, and it will have traveled this distance here. Maybe we'll call it delta Y2. Maybe just a change in Y, and we'll call it delta Y2 is this distance here is going to be 9 times 3.46. So we know what this distance here is. Okay, and so what we can do maybe is maybe kind of figure out what's this, what's V1 here? What's V1? So we'll go over here and we'll kind of draw this line like this here, right? Okay, so we're gonna go ahead and say V1, right, is going to equal whatever VO is, right? VO is plus GT, okay? That's not going to help us out, but we do know this equation here. We'll say final V1 squared plus, or it's going to, hold on, V1 squared, we'll go here, is going to equal VO, right, squared, right, plus 2 times G, and it's going to be this distance here, which is going to be delta Y2. All right, so that'll be the speed. So this will give us V1. So now we have V1, which is right here. So the ball is going to drop, get faster, faster, faster until it hits this position here, which is Y2. So we'll go over here and we'll kind of draw a little line here. So same thing here. We can go ahead and figure out what, so we're going to assume, okay, so brand new problem. We're going to assume the ball goes from here and drops all the way down to here. And what is the velocity here? Okay, we're going to forget about this part and just go straight down. So here, we'll call this here, what, V2? Okay, so V2 squared, right, equals, now this time it's going to be VO squared, okay, because our initial velocity up here is 0, right? It's going to go from here all the way down, okay? And we're going to say plus 2G. Now this time, what is this distance here? From this position to this position, and it's going to be Y2, which we already calculated. So we'll call this here Y2. Okay, so from here, we should be able to calculate what V2 is. So we got the velocity here and we got the velocity here. Okay, so to find average velocity, average velocity, AVG, average velocity is going to be V2, right? V2 plus V1 divided by 2. That'll get us average velocity. And once we have that, now we can figure out what time is between the 2 points, because we know what V2 is. It's going to equal whatever V1 is plus G times T. And then so we want to solve what is T. Okay, we can solve for T, but this has to be in milliseconds. So make sure we move the decimal point. And that's the hints for Dump Tower Level 2. All right, peace out.